Welcome to ClickMyProject.com. The title of the project is Sentiment Analysis for Amazon Musical Instruments User Reviews, and the abstract of the project is Sentiment Analysis is a rapidly emerging domain in the area of research in the field of natural language processing. It has gained much attention in recent years. Sentiment classification is used to verify or analyze the comments given by the user to extract the opinion from it. Sentiment analysis is a machine learning approach in which machines classify and analyze the human sentiments, ratings, opinion, etc. about the product, which are expressed in form of text, star rating, thumbs up and thumbs down. The instrumentation review data used in this process is online product reviews collected from the sample website that we have created. Words such as adjectives and adverbs are able to convey opposite sentiment with the help of negative prefixes. Negations phrase identification algorithm is used to find such words. The performance is evaluated through evaluation measures like accuracy, precision, recall and FN score. And the flow diagram of the project is: first we need to select the musical instrumentation dataset. After that we are going to view the sample dataset in our console working directory. Then it will apply into data pre-processing. In data pre-processing we are going to check the missing values. After that we are going to choose the independent variable and dependent variable, then apply the regular functions to clean the text. Then it will move into Radar sentiment analysis. The Radar sentiment analysis, which is used to find the polarity based on user reviews. So based on user reviews we are going to create the label like positive, negative and neutral. Then it will apply into data splitting. In data splitting we are going to split our dataset into training dataset and testing dataset, because for we are going to cross validate algorithm. There is the only reason which we are going to split our dataset into training dataset and testing dataset. Then it will apply into feature extraction like in pipeline connection. So in pipeline connection we are going to connect the feature extraction method and classification method. In feature extraction we are using term frequency inverse document frequency, which is used to convert the text into vectors like a machine readable form. Then classification we are using support vector machine algorithm and logistic regression algorithm and k-nearest neighbor algorithm. Those three algorithms are pipelined with feature extraction like TF-IDF vectorizer, which is used to extract the features from the input text, and also it will classify at the same times to generate the result in terms of matrices like accuracy, precision, recall and FN. I was successfully executed the program in Anaconda Navigator Spider IDE. So these are all the result of my program. So this is our first module, data selection and loading module. In that I have to read the dataset and then show the sample dataset in our console working directory. After that I have to check the information about the dataset. While checking the information we can properly collect if any columns contains null values, it will show the null values, and also it will show the specific data type for the every column that contains in our data. So then it will apply it into data description method. So in data description I have to check the count value, mean value, standard value, minimum to maximum value of our input data, and then I am going to check the missing values. So in that I have to create the three different labels. One is positive, negative and neutral label. So these are all the data which we are separate the based on the polarity score, and we have to choose in the label for our input data. Then we are going to apply the regular function. The regular function which is used to clean the stopword, stemword and plus special characters from our input data set. Then we are going to find the how to generate the three different word cloud images. So these are the three different word cloud images. So after that we are going to split our dataset into training dataset and testing dataset. Then it will apply into classification. We are applying three different machine learning algorithms. So the first machine learning algorithm is support vector classifier. So the support vector classifier, which is provide accuracy rate is 84%, and these are the classification report for support vector machine algorithm. So in classification report we are going to generate the precision, recall, FN score value for for the positive, negative and neutral sentiments. So the precision means number of correct prediction, recall means number of correct instance of prediction, and F1 score means to measure the test accuracy. Then we are going to find the confusion matrix. The confusion matrix which is used to explain the number of correct prediction and number of misclassified result that we have that is occurred from our support vector classifier algorithm. Then we are going to visualize the support vector machine algorithms learning graph, and also we are going to show the confusion matrix diagram. Then our second algorithm is logistic regression algorithm. So the logistic regression algorithm which achieves the accuracy rate is 84.49%, which is little bit lesser than the SPM algorithm, and these are the classification report for our logistic regression algorithm classification report, and this is the confusion matrix result for our logistic regression algorithm and learning curve for logistic regression algorithm. So in that the training score for logistic regression algorithm is lesser than the support vector machine algorithm. That's why we have to obtain the minimal result of our like compared with SPM algorithm. And this is the confusion matrix diagram, and our final algorithm is k nearest neighbor algorithm. So the k nearest neighbor algorithm achieves the accuracy rate is 84%. So these are the classification report for k nearest neighbor algorithm, and this is the confusion matrix result, and the k-net specificity is 812%. Like